Hi, my name is Zhao Bao. I'm a master's student at Shanghai Tech University in China. I'm also co-author of the paper entitled System Design and Implementation of Transient-Motion-Powered IoT Sensor Node, which was already submitted to SEMASYS 2020. The new Transient-Motion-Powered IoT Sensor Node was developed by the Metal Research Group at Shanghai Tech University. In Metal, we dedicate to the fundamental research on vibration-powered energy harvesting technology and its applications towards self-sustainable Internet of Things systems. The design we are going to introduce is developed based on a vibration-powered IoT platform called Vipson. The whole set of Vipson assembles 6 necessary modules towards a vibration-powered IoT system. The first is a vibration emulator as the energy generation unit, and the second is a piezoelectric transducer as the energy transduction unit, and the third is a power boosting interface circuit as the energy enhance unit. The first is a DC-DC regulator with the energy level indicating signals as the energy management unit, a Bluetooth low power module as the energy user unit, and the sixth is a mobile application as the edge demonstration unit. Vipson helps rapid prototyping and the customizing the vibration-powered IoT systems. Owing to the convenience offered by Vipson, we developed its new derivatives called Vipson E, where E here stands for the energy mode device. In Vipson E, we replace the vibration emulator with a magnetic plug-in piezoelectric beam, such as to catch the energy associated with transient motions. We deploy Vipson E as the real-world scenarios and realize the battery-free motion sensing IoT systems. Let's go inside and have a look. As I opened the door, something installed on the door was triggered. It's just one set of the Vipson E device. Such a triggering has already harvested enough energy from my open door motion, and we can use that little amount of energy to send the movement information to the cloud. Now let's have a slow motion to see how it works. A pair of the repelling magnets carry out such plug-in motion. The moving magnet pulls the other one on the beam's free end. It bends the beam until it reaches a critical bending point. After this critical point, the piezoelectric cantilever is released and starts an underdamped vibration. In our paper, we analyze the plug-in dynamics with a variable potential wheel model. During the open door motion, the beam starts from the bottom of the monostable wheel. As the door moves, the potential picture changes and becomes bistable double wheels. The potential energy of the beam increases as the door continues to move. The swallow wheel will disappear and the ball drops to the other wheel and starts an underdamped oscillation. So that's how we turn the transient moment into a vibration. Only a mechanical harvester is not sufficient to make things connected to the internet. We need a circuit for power conditioning and an embedded system for information processing and wireless transmission. All these functions are implemented in the circuit module. As this in my hand, it's a concentrated version of the 3 modules in Vipson. We use a self-powered SSHI interface circuit, which was also developed by us previously for boosting the harvesting energy. From the charging history after the beam releasing, we can see that the self-powered SSHI can harvest more energy than the standard full bridge rectifier from the same amount of the energy input. The EMU monitors the harvest power level and regulates the output voltage at a specific digital level. It provides an enhancing design to the off-the-shelf LT3 588 chip from the linear technology by inserting an energy build-up period. When the energy build-up is finished, an interrupt will be sent to wake up the sleeping microcontroller. Without the energy accumulation during the energy build-up period, we can only see the unsuccessful trials because the energy always dries up halfway. The EUU is a low-energy Bluetooth microcontroller. It broadcasts the device ID and senses the temperature whenever the accumulated energy exceeds a specific level. Every round of the sensing and wireless broadcasting consumes about 100 microjoule of the energy. The signal sent out from the EUU is a standard Bluetooth beacon signal. It can reach the cloud through the door opener's cell phone or a Bluetooth edge router. Therefore, no matter whenever we are in the real world, once we have access to the internet, we can open the browser and log in to check the running history of our lab. By the way, you might be curious about how we guarantee the harvest energy is sufficient for running the sensing and broadcasting functions, and how we can identify the open door or closed door motions. For the first question, we have done a design tuning and energy analysis such as to make sure the harvest energy exceeds the required energy threshold. We have tested the open door and closed door motions at different speeds and around all the guaranteed 10 times more energy than the aforementioned broadcasting threshold. Therefore, the self-powered solution is robust. Direction identification is realized by asymmetric plug-in design. For the open door motion, the beam finally rests at the bottom of the linear protection wheel, while for the closed door motion, the beam finally rests at the bottom of the monostable wheel. As we can see from the comparison, the heights of the two rest points in the potential wheels are different. Therefore, the amounts of the guaranteed energy are different. The numbers of the sends out the package are different. The receiver can identify the motion directions by counting the package numbers. So what will be the applications of this transient motion powered IoT? Let me go out and give you one example. As WebSense is self-sustainable, we can install hundreds or even thousands of them in our buildings for monitoring the moving things, and they almost cost zero maintenance. As you can see, we have also installed another WebSense at the entrance door of another lab. When I open their door, the system immediately finds someone is intruding. It might also know my identity if the broadcasting signal goes to the cloud through my cell phone. Therefore, this design is beneficial in personal positioning and security monitoring systems. Alright, this is pretty much about our newly developed WebSense device. In particular, we should emphasize the synergy among its mechanical, electrical, and cyber parts towards such a co-design. In future, we will continue to refine the WebSense system and contributing our efforts towards the motion-powered Internet of Things. Thank you.